everybody, and welcome to lesson 3.8. We are going to factor simple trinomials again today, but this time we are going to have to take a few steps before we get to our final answer. So as you saw in yesterday's lesson near the end, there are a few examples where in our trinomial it was in the form of ax squared plus bx plus c, where our coefficient on x squared was not 1. And so we actually had to common factor first. So we're going to focus on a lot of examples like that today. So we will scroll down here. And we'll try a few of those out. So in our first question here, 2x squared minus 20x plus 42. Remember what we talked about in class, how whenever you're given a factor question, you always need to say, can I common factor? So let's take out a common factor of 2. So if I divided this first term by 2, I'd be left with x squared. The next term I'd be left with negative 10x. And then finally a positive 21. So what remains inside the bracket is a simple trinomial because now the coefficient on the x squared term is 1. So we can ask ourselves, we need to find two numbers that multiply to 21 and have a sum of negative 10. So if we think about that, the numbers negative 7 and negative 3 will work out. So as we talked about in yesterday's lesson, this 2, now that you factored it out, just kind of goes along for the ride now. We just kind of continue to write it. But if we focus on this, to factor it, we would say x minus 7 and then x minus 3. And then we'd be fully factored. Okay, I'll try one more with you. Here I can see that 5 is common, and your goal when you are factoring out inside the bracket, you should have a positive x squared. So I'm not just going to factor out a 5, I'm actually going to factor out a negative 5. So that'll leave me with a positive a squared, a positive ab, and then a negative 12 b n squared. Okay, so we need to focus on two numbers that will give us a product of negative 12 and a sum of positive 1. And again, just because there's two variables in this question doesn't mean anything changes. We go from a squared to a to no a at all, and then the b's kind of go in the opposite direction. There's no b, and then there's b to the power of 1 and b squared. So as long as it's in that form, we can still treat it like a trinomial. We want to try and think of these two numbers, which would be a positive 4 and a negative 3. So a plus 4, and remember from yesterday's lesson, when there are two variables, we want to just attach that second variable to that number there. So a plus 4b, and then a minus 3b. For question C, again, we need to common factor, but this time don't just look at the numbers, also look at the variables. So not only is 3 common, but x is also common. So we're going to factor out that 3x and take a look at what happens. Now we're left with an x squared, a plus 2x, and a minus 15. And again, what's left over inside is now a nice simple trinomial where we're looking for two numbers that give us a product of negative 15 and a sum of 2. Positive 5 and negative 3 will work for that one. So we'll write out the 3x, and then one bracket gets x plus 5, and another x minus 3. For question D, I'd like for you to try it on your own. So pause the video here and give it a try. Remember that when you're common factoring out variables, you're going for the variable that has the lowest exponent. So again, give it a pause and try it out. Okay, so now that we're finished this question here, hopefully you noticed that you needed to take out an 8, an x squared, and a y, and it left us with still a simple trinomial, but very similar to question B, so remember to tack on that extra variable at the end. Alright, so what we're going to do now is look at trinomials of different form. So in this question here, we have x to the power 4 now, plus 4x squared minus 21. So it almost looks like a trinomial, but not quite, because we're used to trinomials where we have x squared and then an x. But you can actually treat this particular trinomial just like you would any of the questions that we've done up to this point. As long as the exponent in this first term is double what the exponent is here, you can factor these kinds of questions. So let's give it a shot. We are still looking for two numbers that multiply to negative 21 and add to 4. So those two numbers would be positive 7 and then negative 3. Okay, so now that we have the numbers, remember we're going to have two brackets, just like we would in any of the other questions. But having just an x and an x here, let's say we were to distribute that, x times x is only going to give us x squared. So we need to fix that because we need to end up with an x to the power 4. And that's easily fixed is if you just make these x squareds instead. Okay, but we are still going to put the plus 7 like we normally would and the minus 3. Okay, and always if you feel uncomfortable about your answer, double check and distribute. So x squared times x squared times negative 3, 7 times x squared, oh, I forgot the squareds here, and finally 7 times negative 3. And if we simplify our work, we actually end up with the original question. Okay, so the trick there is to use x squareds instead of x's. And like I said earlier, it works with any pattern where the exponent here is double the exponent on the middle term. So it would work the same if you had x to the power of 6 and 4x cubed, and so on and so forth. Okay, and now for our final question. Let's try and put all of what we've learned into this question. So the first thing is, let's common factor if possible. Well, definitely 2 is common to all terms. I see an x common to all terms, and the lowest exponent on that would just be 1. And that would be it. Unfortunately, there's not a y that belongs to all the terms, so 2x is it. I'm going to divide each term by 2x, so this leaves me with x to the power of 4, negative 6, x squared and y, and negative 27y squared. Alright, so let's look at the pattern. Our x's have the pattern where the first exponent is double the middle exponent. Okay, and then the last term, there's no x at all. The y's do their own pattern. They go up, they start at nothing, and then it has the power of 1, and then power of 2. So we can still treat this question like a simple trinomial. So we're still looking for two numbers that multiply to negative 27 and add to negative 6. So negative 9 and 3 should do it. Okay, so we're still dealing with two variables here, so I know I'm going to have to tack on that y at the end, but my x's, it would make sense to have x squareds here, so that when if we were to multiply it back out, we would end up with the x to the power of 4. So one bracket will get the negative 9 and then the y, and the other bracket will get the positive 3 and the y. And so that question is fully factored. That's it for today's lesson. If you have any questions, make sure you write them down, and we will definitely go over all of this stuff in class. If you want to get a head start on the homework, you can take a look at the textbook on page 241, number 7, 12, 14, and 16. If you are working on 16b, there is a typo in the textbook. You should be factoring this question below. That's it for today. Have a great night.